All right, this is part 2 for the practice for exam 2. All right, part 2, exam 2. Number 1, dealing with imaginary numbers. Square root of -3. I'm going to rewrite this. I'm going to separate this into the product of -3 times -1. Make sure that this is showing up pretty well here. That looks pretty good. All right, I'm going to separate this into 2 separate radicals. Excuse me. Starting off really good here. It's the square root of 3 times the square root of -1. 3 times -1, -3. I'm going to write this as the square root of 3 times the square root of -1. The square root of -3, by definition, the square root of -1 is the letter I. -3I. Notice that the I is not under the radical. And we've got letter B. Letter B. There it is there. Number 2, the square root of -9. I'm going to do the same procedure here. I'm going to write this as the square root of the product of 9 times -1. And then separate each of the factors under a separate radical. I'll write this as a square root of 9 times the square root of -1. And the square of 9, 9's a perfect square, it's the whole number 3, and by definition, the square of -1 is I. And that gives us letter D, 3I. Number 3, I've got the negative of the square root of -28, making sure that I carry that negative sign. And I'm going to separate this into the product of 28 times -1. Now, as far as the square 28 is a composite number, but one of the factors of 28 is 4, and that 4 is a perfect square. So I can rewrite this as 4 times 7 times the square root of -1. Now I'm going to separate this into 3 different radicals. The square root of 4 times the square root of 7 times the square root of -1. Square root of 4, it's the whole number 2 times the square root of 7, and by definition, once again, square root of -1 is the letter I. Alright, so 2, the square root of 7, I, and I believe that's letter D as well. Number 4, it's the product. Here we got it right here. All right, I'm sorry, the product. It's the sum of these two. So if I rewrite this as -8 plus 6I added with 11 plus 3I. Now, a positive sign in front of a parenthesis doesn't affect any of the terms. So basically, I can just drop the parenthesis and have -8 here. I'm going to put the 11 right next to it, 2 whole numbers, plus 6I plus 3I. Notice the plus sign didn't affect anything inside the parenthesis. A -8 combined with a positive 11, well, that's 3. 6I plus 3I, it's like adding variables. 6 of these things plus 3 more of these things is 9 of these things. 9I. 3 plus 9I, and that's letter A. Number 5 here. I'm still trying to get this so it's really visible. Number 5, what do we got here? Yeah, it's the same thing except it's a difference. So I've got 11 plus 9I minus quantity 4 plus 2i. Now, as we well know, the minus sign out in front of the parenthesis changes the signs of the terms within the parenthesis, giving me 11 plus 9i. A minus times a positive is a minus. A minus times a positive is a minus. And now put my like terms together, my constants. 11 minus 4 plus 9i minus 2i. 11 minus 4, that's 7. Positive 9i combined with a minus 2i is a positive 7i. 7 plus 7i, letter B, letter B. Number 6, what do we got? Product. The product of negative 100 times, square root of negative 100 times the square root of negative 9. Now, a common mistake is you think you can just multiply these two, but when you've got the square root of two negatives, you just can't multiply this. An incorrect procedure would be negative 100 times negative 9 would be a positive 900. The square root of positive 900 is 30. That's letter A, but that's incorrect. When these guys are both, the radicands are both negative, you've got to express them in terms of I. So I'm going to write this as 100 times negative 1 times the square root of 9 times negative 1, and then separate these into separate radicals. The square root of 100 times the square root of negative 1 times the square root of 9 times the square root of negative 1. 100 is a perfect square. It's 10. Square root of negative 1 is I times square root of 9 is 3. The square root of negative 1 is also I. Now multiplying these two. 10 times 3, that's 30. I times itself, I times I is I squared, and by definition, I squared is negative 1. 30 times negative 1, the correct answer is negative 30. A common mistake would be to write letter A, because you're multiplying these two, but since they're both negative, you can't do that. You gotta express both these terms in terms of I. Negative 30, which is letter D. Alright, number 7. What do we got here? Quantity. 7 minus 4i quantity squared. To square something means you take that something and you multiply it by itself. 7 minus 4i times itself. 7 minus 4i. And what I'm going to do here is the FOIL method. Product of the first terms. 7 times 7, that's 49. 7 times a minus 4i is a minus 28i. Minus 4i times 7 is also a minus 28i. 4i times the negative 4i times negative 4i is a positive 16. I times I is I squared. So this is 49 minus 28 combined another minus 28i is a minus 56i plus 16, and once again I squared by definition is negative 1. So this is 49. 16 times negative 1 is a negative 16 minus 56i. And let's see, 49 minus 16, that's going to give me 33 minus 56i. And if I look, I see that that's letter C, letter C. Alright, new piece of paper here. What do we got? This is the nasty one. Number 8. These are nasty. What I want to do is the long method, and then what I'll do is create another video, and we'll see if the calculator can make life easier for us. Radical 3 plus 2i divided by 8 minus 5i. Alright, what we need to do is to clear out this denominator, and we accomplish that by multiplying by what's called the conjugate. The conjugate of 8 minus 5i is 8 plus 5i. If I look at my answers, I see my answers, my denominators are all 89 here. If I look at these, all of my denominators are 89. So I'm pretty sure when I multiply, let's see, a positive 8 times a positive 8 is 64. A minus times a plus is a minus 25. I times I is I squared. This is 64 minus 25. I squared is negative 1. 64 plus 25. There it is, 89. But I kind of knew that was going to happen, since all the answers had 89 as a denominator. Now, multiplying the numerator by the same conjugate. And now this becomes a little messy here. In fact, let me rewrite this down bottom here. What have I got? Radical 3 plus 2i times 8 plus 5i. Once again, foiling. Product of the first terms, that's 8 radical 3. Outside terms would be a positive 5 radical 3i. Inside terms would be a positive 16i. Product of the last terms, 2 times 5, that'd be a 10. I times I is I squared, but we know I squared is going to be negative 1. So I'm going to take a little shortcut there. I times I is I squared, but I squared is negative 1. So I'm going to put my two terms that don't contain I together. This would be 8 radical 3 minus 10 plus 5 radical 3i plus 16i. Now this is all over that denominator of 89. Now if I separate these two, I'm going to write this term first here. I'm going to write a negative 10 plus 8 radical 3 over 89 plus what? I've got 5. I'm going to write this 16i. 5 radical 3. 5 radical 3. I plus 16i. This is all going to be 89. Now what I can do here is to factor out the I from both of these terms. So if I factor out an I, it no longer appears in the numerator. Plus 16. And I'll factor out the I. Now if I look at this, this is the letter D. What happened with letter D is the 16 comes before the 5 radical 3. Alright, the 16 comes, so this is written as 16 plus 5 radical 3. Which if I look at it, this is letter D. Those are the nasty ones. So here again, I'll take the time maybe do a video, because it can be done, but it just takes a lot of work. You gotta just hang in there. You just gotta hang in there. Number 9, not nearly as bad, because it's an easier problem. There's only one term in the denominator that has something that's complex. All right, I want to multiply by the complex conjugate. The complex conjugate of 2 minus 4i is 2 plus 4i. 2 plus 4i. Let me take care of the numerator here. Maybe this will give me a clue to what's happening. 4 times 2, that's 8. 4 times 4 is 16 times I is 16i. As I look at the answers, I don't see anything there. I just thought maybe I would just see one answer that had this. Alright, so what's the denominator going to be? 2 times 2, that's 4. 2 times 4i is 8i. Minus 4i times 2 is a minus 8i. Those two would cancel out. Let's see, a minus 4 times a positive 4 is a minus 16. Alright, minus 16. I times I is I squared. So what do we got? 4 minus 16i squared is a negative 1. And this becomes 4 plus 16. That's going to be 20. Now what I'm going to do here is to write both of these terms in the numerator over 20. So this would be 8 over 20 plus 16 I over 20, and something tells me, oh yeah, all right, this is not 4, I wrote it wrong, this is 14. 14. How does that change things? Well, it changes things because it makes this 14 times 14 doesn't make it, makes this 196. Wow. That was a huge mistake. 196. 196. 196 and 4. Not 20, it's 200. 200. The lowest terms is to be 1 over 25. And then 16 divided by 200. That would be 7 over... No, this would be 96. 96. 96. All right. And 8 would go into... Mr. Gomes can't multiply today. 4 times 14 is not 96, it's 56. Sorry for the miss. What happens? Alright, 8 into 56, 7 times. And 8 into 200 goes 25 times. And I'm factoring out the I. Wow, letter C. Problem is, here again, if you're doing the problem out and you're getting an answer that doesn't even appear there, go back and look. And my problem was I just flat out copied the problem wrong. It wasn't 4i, it was 14i, which caused all kind of problems. All right, so it happens. If you're doing it and things aren't coming out correctly, chances are you've copied the problem. That was my issue here. It wasn't 4i, it was 14i. Well, number 10. What do we got here? I to the 44th power. Now, I could use my calculator. In fact, I'll show you number 10 on the calculator. But the rule I've been talking about is to take the exponent, divide it by 4. 4 goes into 44 11 times, and there's a remainder of 0. And that is the power of I. Whatever the remainder is, we divide the coefficient by 4. That's your power of I. I to the 0 power. Well, we know that I, anything raised to the 0 power, is the whole number 1. Your calculator will do this, but it gives you some nastiness, and it has the letter E. And you're taught in the videos to ignore the portion of the answer on the calculator that has the letter E. If you put in I to the 44th power, you would have gotten 1 plus something to the letter E. I'll try to do this one on the calculator to show you. It's a little bit easier. Number 11, 2i raised to the 4th power. You should have copied it right. So to raise to the 4th power means to take 2i and multiply, or use it as a factor 4 times. 2 2s are 4, 4 2s are 8, 8 2s are 16. I times I times I times I is I to the 4th power. And you're taught that I to the 4th power is the same thing as positive 1. I to the 4th by definition is positive 1. 16 times 1, well, that's simply 16. That's the letter B. I to the 4th power 1. All right, so we know that I is just I to the square is negative 1. I to the 3rd is negative I. And I to the 4th is positive 1. Those are the 4 values. Here you go. I to the 1st is I squared is negative 1. I to the 3rd is negative I. And I to the 4th power is positive 1. Got it. Number 12. Let's see if I have the graph. He's asking me for the x, and the x-intercepts in zeros. They're kind of one and the same here. I've got a 0 at -6, and I got another 0 at -3. All right, -6 and -3. -6 and -3. All right, which means that my x, those are my x-intercepts, so my solutions, my zeros are -6 and whoops, I'm sorry. Yeah, -3 and -6, -3, -6. Here we are, the graph's cutting across the x-axis. Right here at -6, and also at -3. You can see it right there, -6, -3. All right, quadratic formula. Number 13. X squared minus 12x plus 45. There's two videos where I actually walks you through programming your calculator to do the quadratic formula. Alright, so what is the quadratic formula? It's the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. X is equal to. Alright, what's my a value? My a value is positive 1. My b value is negative 12. And my c value is quite large, 45. So the opposite sign of b, the opposite of a minus 12 is a positive 12. Plus or minus b squared. I'll write this minus 12 squared minus 4 times a times c. A times c, well that's 45. Alright, so just give me a second here. It's just shaking like heck. So what do we got? And all of this, of course, divided by twice a. A is 1, so twice 1 is 2. So this is 12 plus or minus the square root of minus 12 squared, that's 144, minus 4 times 45. That's going to be a minus 180. All of this divided by 2. So 12 plus or minus the square root, let's see. 144 minus 180, that's a negative 36 divided by 2. Now I can write negative 36 as the square root of 36 times the square root of negative 1, which is letter I. Square root of 36, well that's just 6. 12 plus or minus 6i over 2. Now canceling the 2 with all of the terms. 2 into 12, well I can write it this way. 12 over 2 plus 6i over 2. 12 divided by 2 is 6. 6i divided by 2 is 3i. 6 plus 3i. In fact, it should be a plus or minus. Plus or minus. And that is, I believe, letter B. Letter B. Quadratic formula. Once again, if you take the time to program your calculator, all you have to do is input the A, B, and C values in, and the calculator will help you out immensely. It'll do all the work for you. It's not that hard to do, says he who can't multiply, can't write the problem down right. All right, number 14. The equation is x squared equal to 12 plus 3x. I'm going to put these two terms on the left side. X squared minus 3x, bringing this over as a negative. Positive becomes negative on the left side. So my A value is 1, my B value is minus 3, and my C value is minus 12. quadratic formula, x is equal to the opposite of b plus or minus b squared minus 4ac over 2a. The opposite of a minus 3 is a positive 3, plus or minus b squared. If b is minus 3 squared is 9, minus 4 times a times c. A times c would be a minus 12. Would be a minus 12. Give me a second. And all of this divided by 2a. A is what? A is 1. Twice 1 is 2. So this is 3 plus or minus the square root. A minus times a minus is a positive. 4 times 12 is 48. 48 plus 9 more is 57. And all of this divided by 2. And I'm pretty sure that's just the way they have it. 3 plus or minus the square root of 57 divided by 2, yeah. That's letter C. That wasn't so bad. That wasn't so bad. Alright, so what do we got? Number 15. 15 is asking me to find a vertex. Here's my function. F of x is equal to 3x squared minus 12x plus 2. The vertex is defined as the opposite of b over 2a, comma, f of minus b over 2a. Alright, so my a value is 3, my b value is minus 12. So I want the opposite of b, the opposite of a minus 12 is 12, divided by twice a, twice 3 is 6. So this is 2. So I know the x value of my vertex is 2. Now if I look at the answers here, there's only one answer that has an x value of 2. And there it is. So there's no need of me finding the y value of my vertex. If I pop 2 back into this, yeah, I'll get minus 10. But look, there's only one answer. That's a positive 5. That's a minus 5. This is the only one that had the correct answer. So why put yourself through more work? There it is. If I put 2 back into this, I would have got 2 squared is 4. That would have been 12 minus 24 plus 2. That would have been 14 minus 24. That would have definitely given me a minus 10. But I didn't have to do that. Once I knew this was right, there was only one answer that had the correct x value for the vertex. Number 16. The function is defined as g of x equal to x squared minus 11x plus 8. My a value is 1, my b value is a minus 11. So my vertex is minus b over 2a, comma, f of minus b over 2a. Simply meaning once I know what this is, I put it back into the function. In fact, it wouldn't be an f. Function is defined as g, but the idea is once I found this value, pop it back into the function, and you'd find your y value. Alright, so minus b. B is a minus 11. A minus b would be a minus times a minus, a positive 11, divided by 2a. If a is 1, twice 1 is 2. Now check your answers out and see what happens. Well, here's a case where I got 11 halves. B has 11 halves and D has 11 halves. So unlike the previous one, I got 2 with the right x coordinate for the vertex. So popping in 11 halves back into the function, the function is g of x equal to x squared minus 11x plus 8. So what's g of 11 halves? G of 11 halves would be 11 halves squared minus 11 times 11 halves plus 8. This would be 121 over 4 minus 11 times 11, 121. I get this written right. 121 over 2 plus 8. So I would need a common denominator here. I would need a common denominator. So 121 over 4. If I made this into a denominator of 4, I would double this and double that. So this would be 242 over 4. And 8, I could rewrite 8 as 32 over 4. Alright, so I get everything over 4. If I combined a 121 with a minus 242 and a positive 32, I'd get a minus 89. Yeah, some big numbers there. Alright, so the one that had, right here, letter B, had the correct x value and now the correct y value, minus 89 over 4. So the problem was, the hard part was popping in 11 halves into this here, making sure you multiply, rename all of this as a common denominator of 4, and combining all your terms and getting minus 89. Bit of a hassle. Bit of a hassle. Could we have graphed it and found the answer a little easier? Probably. Probably. Number 17. He's asking me to find the axis of symmetry. The axis of symmetry is x is equal to minus b over 2a. That's going to be easy enough. 17. F of x equal to x squared plus 17x plus 6. So my a value is 1, my b value is 17. So minus b over 2a. A minus times 17 is a minus 17. Twice 1 is 2. So my axis of symmetry is x is equal to negative 17 halves. That's pretty straightforward. Alright. Only problem is I wrote the problem wrong. It's a negative x squared. Negative x squared. Which means this is a negative 1. Which means that twice a is a negative 2, and it makes that a positive. Here again, it helps to make sure before you do the problem, you make sure that you've got it copied right. Alright, that was a negative x squared, which made a negative 1. Doubling it is a negative. A negative over negative is a positive. Alright. Number 18. G of x. G of x is 3x squared minus 42x plus 155. So my axis of symmetry is x is equal to the opposite of b over 2a. What's a? A is 3, b is a negative 42. Making sure I get this bad boy copied right. So the opposite of a minus 42, minus b, minus a minus 42 is a positive 42, twice a. A is equal to 3 twice a is going to be 6. And 42 divided by 6 is 7. So my axis of symmetry, x is 7. A lot easier than the previous one. A lot easier. Well, not the previous one. Previous one, the problem was I didn't copy it right. That's a negative. 42 divided by 6. The opposite of b over 2a. The opposite of a minus 42 is a positive. Twice 3 is 6. 42 divided by 6, 7. Alright. What do we got? 19. Looking at number 19, he's asking me, here again, best way to do this, and I'll do this on another video. You've got a parabola that has a positive a value, so you know it opens upward, all right? If it opens upward, it's got a minimum point. So it can't be C and it can't be D. All right, in graphing this, you would have found that the vertex here was down at -10. All right, but you knew if this is a positive, if parabola opens upward, you're not going to have a maximum point. You're going to have a minimum point. So these two are out of the picture. And the minimum point was -10. And I'll do that on another video. And the same thing here with number 20. All right, I'll actually graph this. Let me just see something here. Looking at this, well, I know it opens upward, so it can't be this guy. And it's got a, problem is it's either going to be letter A or letter B, because it goes through, well, I take that back. I'll graph this on, yeah, I'll do it with a calculator, all right. I know it's not letter D. All right, so much for that.